And let me send you to the first practice quiz question. State the question that's asked to find the vertical asymptote. What's the question you ask yourself? "30 seconds more." The question is, what input causes the denominator to be 0? Kind of like this. Fx is equal to 3 over x minus 5. We would say x equals 5 is the answer to that question. That causes the denominator of this fraction to become 0. That is the vertical asymptote of this function. If we were graphing it over at 5, we would put vertical dotted line. The graph is going to do something like this. Around it, it goes up super high or super low. Never touches the vertical asymptote. Next one, state the question that's asked to find the horizontal asymptote. This one I anticipate will be tougher because you had some homework problems with the vertical but not the horizontal yet. But see what you can dig up. Don't look it up. Dig it up from your memory archives. Take a guess if you can't. Very important to take that guess. Ten seconds more. As the input gets super large, what happens to the output? And when we were doing this, before, remember we had looked at McDonald's advertising, sales and dollars spent on advertising, and we at first thought, you know, if the data shows that sales go up as you spend more on advertising, maybe it's going to go up and up and up, but common situations like this are where we have a horizontal asymptote. After a while, you've saturated the market with advertising, it doesn't do any more good, and we hardly get any more. So as we get anywhere near a horizontal asymptote, you'd probably want to stop your spending on it. Not very efficient. And all right, give me feedback on these two questions. How you did in remembering them, and how you feel about those basic ideas. Are these classes recorded? Yes, every single one. And to get to the recordings, let me just show you real quick. You go into the modules and the upper modules. Very first thing says class videos, before even module 0. And later in the same day, it takes a usually a few hours before I get them fully uploaded into YouTube. But then they're available right here. Alright, and then find the x and y intercepts. The textbook calls these horizontal and vertical intercepts. And the vertical asymptotes. And do part A to start with. Okay, and group leaders, remember, give me, state, go into your group, say hi, group leaders, tell me first name, everybody's here today, and make sure you let your group know who the group spokesman for the day is. Okay, 30 seconds more. So, x and y axis. To find an x-intercept, you set the opposite letter, y, to be 0. When you set the y to be 0, y is the height above the x-axis. That x height is 0 for any point, so then you're just going to get x coordinates, but they'll have to be on the x-axis. So you set y equal to 0. That gives you 0 equals 3 divided by x minus 5. Now this has no solution. How do I know that it has no solution? Well, a fraction can only be 0 if the upper part, the numerator, is 0. If the denominator is 0, that makes the fraction undefined. Now the numerator can't be 0 because it's stuck at 3, so it just has no solution. The technique you might use is you might try to multiply both sides by x minus 5. These would cancel, and you would get 0 on the left and 3 on the right, which is a nonsense equation. 0 does not equal 3, because anything times 0 is 0. And that also is an indication that there's no solution. Right? And then, so there's no x-intercepts. For the y-intercept, you set the x equal to 0. And then you're going to get y, or f of x, is equal to 3 over 0 minus 5, which is negative 3/5. So that, if here's negative 1, negative 3/5 would be somewhere like this. So the y-intercept is really a point in space, 0, negative 3/5. I prefer the answer for intercepts. Give me both the x-coordinate and the y-coordinate. For y-intercepts, it'll be 0 over, and then when you go 0 over, all you can do is go up or down, so you'll be guaranteed to be on the y-axis. And then negative 3/5. Then the vertical asymptote is you just answer the question. What input causes the denominator to be 0? that will show up as a dotted line on the graph of this. Now, I'm not going to require you to be able to construct the graphs from this, but I am going to ask that you be able to make sense of it, that once you see the graph, that it makes sense. The graph on this one is going to look like this. It's infinitely close to that horizontal asymptote, to that vertical asymptote. And over here it's going to go like this, getting infinitely close to that vertical asymptote, like that. The part about the asymptote should make sense. It's a little bit tricky to figure out which side it goes up on and which side it goes down on. And if you're interested in that, it's not too hard to tell. Let me show you. If you made a little table of values, of course you don't have to do this, but it might be helpful for you to understand it. 3 over x minus 5. If you are at 4.99, you're going to get 3 divided by a small negative number. And the key thing is it's negative. So you're going to get a large negative number. That's why you get it at 4.99, just to the left of 5 is going way down to negative infinity. If you were just to the right of 5, you would have 3 divided by, now 5.001 minus 5 is a small positive number. So you're going to get a large positive number, and that's why we're way up on that side of it. Alright, so give me a little feedback on 3a. Okay, Sasha says, still confused how to get the asymptotes. A little bit fast. It's good. Somebody needs to mute.
No, sir.
Could you mute your mic? Thanks, getting a little feedback there. Alright, to get the vertical asymptote, the question is asked, what input causes the denominator to be 0? So I come back down here, and I see if x is equal to 5. It's the same thing if you were stating the domain. You'd say x cannot be 5. That's the vertical asymptote. Okay? And that causes a vertical dotted line at 5. The equation of x equal 5 is in fact a vertical line. It's that vertical line, that green dotted line. And then this function, x can be anything it wants to except for 5. And how come x can't be 5? If x is 5, you're going to get 3 divided by 0. And we had looked at that before. Something like 3 divided by 0 doesn't make sense if you tried to even put it as 0. 0 times 0 does not equal 3. And ask, remember like 8 divided by 2, we said, how many times do you have to add 2 to itself to get to 8? You add 2 to itself 4 times, that's why this is 4. And then it checks this times this is this. How many zeros do you have to add together to get to 3? If you did an infinite number of them, you're still stuck at 0. So this is undefined. 3 is infinitely larger than 0, more than infinitely larger. Infinite number of zeros doesn't even get you 3. So it just doesn't make sense. All right. Now, when you get 3 divided by a really small number, like 3 divided by 0.001, now that's 1/1000th. You have to add that together 1,000 times just to get 1. So this is going to be 3,000. You get huge numbers. The smaller this number gets, the bigger the fraction gets. And you get these really small values when x is just barely bigger than 5. And if x is barely smaller than 5, you'd have something 4.99 minus 5 is a small negative number. All right, let's go to the next one. B. Find the x-intercept, the y-intercept, vertical asymptote, and if you're up to it, draw a bit of a sketch on how the graph might look. Excuse me. Okay, 30 seconds more. Okay, let me have you stop. So notice this subtle thing. X-intercepts plural. Y-intercept singular. No S. So you always only have one y-intercept, because otherwise it wouldn't be a function. A vertical line might hit, if it had more than one y-intercept, a vertical line would hit the graph more than once, so it wouldn't be a function. But you can have it hit the x-axis multiple times. This one doesn't hit the x-axis at all, but many times we have functions that hit the x-axis many times, and that's fine. That'll pass the vertical line test. All right. So x-intercepts, you set the opposite letter, y equals 0. 0 equals 3x squared minus 9 for x minus 1. Now, this is a fraction. The only way a fraction can equal 0 is if the top of the fraction is 0. Now, so I could just ignore the bottom and say 3x squared minus 9 must be 0. Or I could do this. Multiply both sides by what's in the denominator. And this and this cancel out. But 0 times anything is 0. And you get 0 equals 3x squared minus 9. Now, I want to solve this now. I'm going to factor out a 3. And I get this. Then I'll divide both sides by 3. And then I get, I'm going to need some more space here. I'm going to get 0 equals x squared minus 3. I'm going to add 3 to both sides. Turn it around. I'm going to take the square root of both sides. I'm going to take the square root of both sides. I'll insert plus or minus. I'll get x equals plus or minus square root of 3. And then the x-intercepts are square root of 3 is 0 and negative square root of 3 is 0. Now square root of 3, if I punch it out on my calculator, I'm going to punch that out right now. It's about 1.73. Something like that. So I could give an approximate answer, that would be fine as well. Alright, now the y-intercept, this will be easier. Set the opposite letter, x equal to 0. So then you're going to get f of x or y equals, now you're going to get negative 9, because the 3x squared all just zeroes out. And 0 minus 1 is negative 1, is equal to 9. So the y-intercept, the x is 0, the y is 9. Vertical asymptote. You ask the question, what is the value of x that causes the denominator to be 0? The answer is x equal 1. That's the vertical asymptote. So if I was graphing this, let's say 0, 9 is way up here. And then square root of 3 is about 1.7, right around here. Same thing right around here. Okay. And the vertical asymptote is at x equal 1. Now, this one, too complicated for me to want to try to figure out what the graph of this one looks like. But I could do this. Remember what it is, 3x squared minus 9 over x minus 1. I can go to any graphing utility to kind of check to see what the graph looks like. My favorite math graphing utility, I'll go to that right now, it's called Wolfram Alpha. And if you go to wolframalpha.com, and it's just super easy to use, it's just one line of input. And if you don't know the lingo, how you're supposed to do something, you just use normal English and it'll figure it out. Graph y equals, what is it, x squared, no, 3x squared, minus 9 divided by x minus 1. Even this, I'm like, did I type that incorrect or not? Well, if you just hit enter, it'll re-show it again. Yeah, that's what I wanted. And then it shows the graph. And is it hitting at about negative 1.7 and hitting the x-axis about positive 1.7? Yes. Is it hitting the y-axis at about 9? Yes. And we set a vertical asymptote at 1. Yeah, that looks right. It's getting closer and closer to that line. It doesn't show the vertical asymptote, but there it goes. This graph now makes sense in the light of this information over here. All right. Give me feedback on B. Let's go back. Let's do it again. New function. Give the x-intercept, y-intercept, vertical asymptotes. Okay, 30 seconds more. So put what information you do have in the form of a graph, kind of like we did with the last one. You don't draw the entire graph, but whatever information you do have. Alright, so the x-intercepts, we set the opposite letter, y equal to 0. We get 0 equals 2x minus 6, x minus 5, x plus 2. Now, although this is complex, it's one fraction. That one long fraction bar tells you it's one fraction. How do you get a fraction to be 0? Only if the top is 0. If the bottom is 0, the fraction is undefined. So we could multiply both sides by what's in the denominator, or we could just realize that the top has to be 0. And then I'm going to solve this. Divide by 2. So 3 comma 0 is the x-intercept. Go to the y-intercept. Set x equal to 0. And then the y, or the f of x, will be, all you'll get is negative 6 on the top, and negative 5 times positive 2 on the bottom. So it's the same as 6/10 or 0.6. So the y-intercept is, the x is 0, and the y is 0.6. Vertical asymptote, there are two of these. What input causes the denominator to be 0 when x is equal to 5? because then you'd get 0 times 7, which is 0. Or x is equal to negative 2, which is negative 7 times 0, which is also 0. And if we put all this information together, we would get a graph looking like this. 3, 0, there's an x-intercept. 0.6, there's a y-intercept. And then 5 is a vertical asymptote. Negative 2 is a vertical asymptote. And this one's going to be too complicated for me to want to look at, but I'm going to do the same thing. I'm going to say 2x minus 6 divided by these. I'm going to put it in Wolfram alpha and see if the graph that I get from there is consistent with this. X minus 5, I think I'm remembering this right, x plus 2, and then hit enter. Okay, and then look at my graph, and I compare this. Oops. Oh, I need both of those things in the denominator. So I'm going to need an extra parenthesis. Notice how it only put the first one in the denominator and the second one it multiplied. Now that's showing me how it interpreted it. And that, let's see how that matches. Alright, so it looks like my function now, and it should have an x-intercept, 0.6, and a x-intercept 3, y-intercept at 0.6, x-intercept 3, y-intercept 0.6, that looks right. And it should also have vertical asymptote at 5 and negative 2, these two vertical asymptotes. At 5, yep, it looks like it. And negative 2, yep, looks like it. So it all's confirming with this. A little feedback on part C. Okay, sometimes you got to see it a few times to really get it here. Okay. Alright, now, before I go on, let me interrupt here. Any questions on the homework? Any questions on anything at this point? For the homework, you only had to do the vertical asymptote portion. Anything about the horizontal asymptote, we hadn't finished that up. So if you have questions with regard to the horizontal asymptote, hold those questions. I'll be addressing that next, but any other questions? And it can be about anything. Structure of the course, or the meaning of life, whatever you want to ask about.
Mr. Shankin?
Yes.
I had a problem with number 24 on the homework.
All right. This is 5.624. Find the x and y intercepts. All right. And who is it that's asking for this? What's your name? So number 24, the x-intercept.
I'm sorry, this is Brianna.
Brianna, okay, thanks. All right, x-intercept, we'll set y equal to 0. Okay, now this is a fraction. So the only way a fraction can be 0 is if the top is 0. So this top part must be 0. So I'm going to get 94 minus 2x squared equals 0. I'm going to add 2x squared to both sides. I'm going to divide both sides by 2. And we got x squared. Half of 94 is what, 47? So then I take the square root of both sides. Introduce a plus or minus sign when you do that. The reason why you have to do that is if you just think of a really easy problem. X squared equals 9. Take the square root of both sides. If you didn't put plus or minus, you'd only get 3. But negative 3 times itself is also 9. So you got to introduce that plus or minus sign. Okay, so the x-intercepts are positive square root of 47 causes the y to be 0, and negative square root of 47 causes the y to be 0. And then we do a similar setup for y-intercept. But this will go quicker. When you set the x equal to 0, y, it'll just zero out all the terms that contain x. You get 94 over negative 12. And this is a negative answer. And let's divide each by 2. 47 over 6. And that's the same as 6 times 8 is 42. And then there's 5, 6 left over. Okay, so the y-intercept is 0, negative 8, and 5, 6. Okay. Brianna, does that answer your question?
Yes. I do have another one, and is that okay?
Yes.
It's number 27, and it's about local behavior and end behavior on one of the fractions.
27. Describe the local and end behavior. Oh, I was supposed to skip that because we hadn't covered that. I think I still had that listed in the assignment list. All right, sorry about that. The assignment should have gone 6 through 24 multiples of 3x, not 6 through 27. All right. That's, though, something from college algebra. We're not really covering it here, but I can review it. So let me do it real quick. Oh, I need a little more space here. All right, let's review this because it's a good idea, good good topic to know something about. So I'll look at 27. All right, the end behavior of a function is another way of saying horizontal asymptotes. We're going to be getting more into horizontal asymptotes today. So it's asking what, remember the question for horizontal asymptote? As the input gets super large, what happens to the output? That's the end behavior, because it's asking what's happening way at the end of the function, way over here on the x-axis. Does eventually this go up forever? Or does it come down to the x-axis? Or does it have a ceiling that it never gets through? All that stuff, end behavior is all about horizontal asymptotes. Now, how we get to that in this particular problem, it gets a little tricky here. So let me save that. Now, the local behavior would be more like what happens in between the ends, the far right and the far left, and you have things like x and y intercepts. And typically, if you answer the local part by just stating what the x and y intercepts are, and then this is a great lead-in then to our subject. And we're going to go to horizontal asymptotes, and we're going to finish that up from last time. But we are at our break time, so we will start again at 1:30 p.m. And does anybody need to speak to me individually before I take my break? Okay, see you in 15 minutes. Alright, we will start back up again now. And horizontal asymptotes. Let's finish this up from last time. So again, the question that's asked for horizontal asymptote is, as the input gets super large, what happens to the output? And so look at this one right here. Answer that question. So state the horizontal asymptote of this function. And it's really the answer to the question. I'll give you a quick minute.
Right. Some Robert, this is exactly what I needed help with. Right.
Good. Alright, and let me, here we go, put a little more space here. I can answer this question by making a little table. And when x is, let's say, 100, now it's starting to get large, you're going to get 3 over 95, which is pretty small. When x is 1,000, you're going to get 3 over 995, which is even smaller. Notice these are all positive, but getting smaller and smaller. As this gets bigger and bigger towards infinity, this goes towards 0. It gets closer and closer to 0. You're going to get smaller and smaller numbers over here. So, as x gets super large, why? The answer is y gets closer to 0. Thus, the horizontal asymptote is y equals 0. Now, what does this mean about the graph? When I graph this thing, you already have some other information about this. You might have an x-intercept. You might have a y-intercept. You have a vertical asymptote. You know it has a vertical asymptote at 5. But now you also have this horizontal asymptote at y equals 0. All right. So this one, when I graph it, it looks like this. It's got 2 asymptotes. As I get closer and closer to this, as I get closer and closer to 5, I get closer and closer to this dotted line. And the horizontal asymptote, I would put a dotted line, except there's already an x-axis there. Sometimes I, do this, extend it, so that you can see, that last part should be horizontal here. Okay. So now this graph will also look something like this. So it goes to the horizontal asymptote, generally on both ends. If it's going over here, it'll probably go over there as well, like this. And so the vertical asymptote, is there some place where it's just going through the roof? Horizontal asymptote is there some, what happens as x gets super large? Is there a floor that we never go underneath, like in this case, or a ceiling that we never get above, like in this case? And let's go to state the horizontal asymptote of this next one, g of x. Give you a quick 30 seconds. What's the horizontal asymptote? So as x gets, or as the input gets super large, what happens to the output for this function? Well, when the inputs are really large, the outputs are even larger. Like if x is 100, this would be quite a bit larger than that. And so what does this say? Well, when the graph has to do with n behavior, way to the right, this thing is going off to infinity. And if you try to impose a ceiling and say, you can never get above this, no, it would crash right through any ceiling. So we say that this has no horizontal asymptote. Okay, this is still part of the practice quiz because we had done some of these things before. So give me a little feedback on how you're feeling about 4a and 4b with the horizontal asymptote. For C. The directions again are state the horizontal asymptote. Just copy that again. State the horizontal asymptote of that one.
Expand a little bit, Robert. It just got small all of a sudden. I don't know.
Let me make it larger.
Yeah, thank you.
Thanks to the input. State the horizontal asymptote of that function. Okay, 30 seconds more. So, if I was to make a table of values, and if I put large numbers like 1,000 here, this top number is large, but this one is way larger. Now, if you have a large number in a fraction, but a way larger number, remember, a fraction is the ratio. How many times this is bigger than this, or in this case, it's smaller than that. So you're going to get something really close to 0. And the larger this gets, as this goes towards infinity, the more and more this is going to go towards 0. Right here. So the horizontal asymptote, once again, is, we'll put the colon, y equals 0.
Is there a pattern with these? Like if it has like on the denominator, if it's subtracting, does it typically go towards 0? Is that like just some?
Good question, Jordan. Does it have to do with the subtraction sign in the denominator? Or what's the big characteristic? If we were kind of stepping back a little bit and trying to understand this, what lets us know that this had a horizontal asymptote of 0? Anybody want to take a shot at answering that? What's the pattern involved here?
Is it that the exponent is, there's a much larger exponent in the denominator?
Very good. If we have a larger exponent,
Thanks, Lee.
in the denominator. Yes, Jordan.
I was just thinking, Lily, that's cool. I didn't even see that. That's awesome.
And it makes sense though, huh? Then the horizontal asymptote is y equals 0. Because the denominator is going to grow bigger faster than the numerator, making the fraction smaller and smaller, driving it to 0. So, and the terminology we use is the degree. And we had this problem yesterday. State the degree of this. This is degree 3. It's the largest exponent that occurs in the polynomial. So we look for the thing that has larger degree. This is a second degree polynomial in the numerator, fifth degree polynomial in the denominator. So the one with the larger degree dominates, it drives the whole fraction down to 0. That's its horizontal asymptote. Alright, now let's come back in rational functions over here. We had done these things before. And the three that we had done, today is Tuesday, last week on Thursday, we had done these three problems. Notice there's the only polynomials in the denominator. So the numerator stuck at 1. As the denominator gets bigger and bigger, it drives the fraction to 0. This one didn't have a fraction. So when there's no fraction, as x goes to infinity, the y will also go to infinity. This one, the bigger one, the polynomial was in the denominator, and the numerator stuck at 2. So it drives the denominator bigger and bigger, drives the output to 0. Alright, now this one would be in a similar way, that the degree of the numerator is 2, but the degree of the denominator, let me make it a little bigger, the degree of the denominator is larger than that, so this drives the whole thing down to 0. Okay. So this is degree 2 over degree 3. So larger degree in denominator. So then horizontal asymptote is y equals 0. Alright, so this function, I don't know what it looks like when I graph it, but I do know that way over here to the right, it's going to be going towards 0. It might be coming from the top, it might be coming from the bottom. I'm not going to get fussy. But either way, it's going towards 0. And it'll probably do the same thing on the other side as well. Alright, so let's look at the bigger idea here. Notice, if it's not a fraction, it has no chance of having a vertical asymptote. That was like this one. As x gets bigger, so does y. If it's a fraction, and the denominator gets larger faster, and the denominator gets larger faster than the numerator does, so the bottom's getting bigger faster, then the horizontal asymptote is y equals 0. We decide which gets faster, the numerator or denominator, by examining the degree of the polynomial. It only matters what the degree of the polynomial is. The one case that we haven't looked at yet is, what if the numerator gets larger faster than the denominator? So, state the horizontal asymptote of this one. Let me give you 30 seconds. And pop into your group chat, and at my cue, state what you think the horizontal asymptote of this one is. go ahead and input your answer to your group chat. See what other folks have. Okay, group 4. Horizontal asymptote. What do you say about the horizontal asymptote here? Group 4. I don't think Mushi's here. Mia, you're the backup group leader. What do you have? You're not here either? Okay, let's go to group 2. Group 2, what do you got for this?
Would it be getting closer to 1?
Why'd you say 1?
Well, we just figured because if the degree is large in the denominator and it gets closer to 0, if it gets larger in the numerator, then it should be getting closer to 1.
Well, let's see. That's an interesting, very interesting hypothesis. So you're saying if the degree is higher in the denominator, it drives it down to 0. So if it's higher in the numerator, maybe it goes to 1. Very interesting. Let's suppose, let's jump right up to like a big number, like fairly big 100. Now, if you did 100 to the 4th power, that's 100 times 100 times 100 times 100. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 8 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. You're getting a really big number. Now, this is minus 3 with only 4 zeros. Notice this one is so small compared to this one, we can basically ignore it. Plus 2 with only 2 zeros, and it's so small compared to this one, we can basically ignore these. These are like insignificant. And then if we do this one, it's 9. When you take 100 squared, you just have 2 of these, and you get 4 zeros. Plus 3 with 2 zeros, plus 1. Now these two are so small compared with 90,000 that the answer is approximately 90,000. Now, what you're going to get is, you see, as x gets really large, all the focus goes on this. These become insignificant. And how much larger when x is 100 is, do you remember this question? X to the 43rd and x to the 42nd. I had this on Thursday, something like this. If x is equal to 100, these two both look giant, but this one will be 100 times larger. Because it has an extra 100 in it. It'll be 100 times larger than that one, right over here. And so this one will become kind of like insignificant if you were like comparing their ratios. And this over here, this is a lot bigger than this. This ratio, this would have to be the same size as this one for that to turn out to be 1. As x goes off to infinity, getting larger and larger, this side also is going to go off to infinity. If the degree of the numerator is higher than the degree of the denominator, we get no horizontal asymptotes. None. There's no ceiling there. And that was a good guess, though, of 1. I haven't heard that before. And that was very interesting. So thanks for that input. Any questions on this? All right, let's go to the next one. State the horizontal asymptote for f of x. Put your answer into your group chat. Okay, group 3. What do you have for this? What's the horizontal asymptote here?
I'm not sure about it. I didn't see any other feedback in my group, but
No feedback yet on this one?
feedback, yeah.
Okay. Let me go to group 1. Any ideas? Horizontal asymptote for this?
Did you say group 1?
Yes.
Oh, okay. We said I got some feedback. Let me just see real quick. There will be no horizontal. No acetate.
No, that's right. There will be no horizontal asymptote for this. Why is this? Because as x gets really big, you get a big number on the bottom, but you get a huge number on the top. And the ratio of a huge to a big is really, really big. And as this gets larger and larger towards infinity, so does this. The top gets much bigger than the bottom. It goes off to infinity. All right. And there's one other case. What if the degree of the numerator is equal to the degree of the denominator? And because we'd seen, well, if the denominator is larger, then the horizontal asymptote is y equals 0. If the numerator is larger, then no horizontal asymptote. But if they're equal, state the horizontal asymptote of this one. All right. And this one, I'm going to work it out. As x goes to infinity, it's getting larger and larger and larger. These things become less and less important. They become really small compared to everything else. Compared to that 4th degree term. So what you wind up comparing is this. And if x was, let's say, 1,000, then this thing is going to be 8 with a whole bunch of zeros. 12 zeros, because there's 3 zeros 4 times. And that's the shortcut notation for that. But the bottom will be 2 with 12 zeros, like this. They will have the exact same number of zeros. These two things will divide out. And you will just get 8 divided by 2, which is 4. And what we say is the horizontal asymptote will be 8 divided by 2, which is 4. And it's the ratio of the leading coefficients. This is called the leading coefficient. We call this whole thing the leading term. And this one is the leading coefficient. So if you put them in order highest degree first, then the term that has the highest degree is called the leading term of the polynomial. And then the number out in front is called its coefficient, the leading coefficient. And this is what we call the ratio of the leading coefficients. Eight divided by 2, thus it's 4. Horizontal asymptote is y equals 4. Now, it turns out this is the only way you can get a non-zero horizontal asymptote, when the degrees of the polynomials are the same. And then, because we always get either 0 or there's none, the only way we get anything else is if the degree is equal on the numerator and the denominator. So, you do this next one. State the horizontal asymptote. For this one. Okay, enter your answer into your group chat. And group 2, what do you have for the horizontal asymptote here?
We got y equals 1/3.
Very good. All you do is you take, see, these guys become insignificant. And the x squareds are just going to cancel out. You're just going to get 3 over 9, which reduces to 1/3. And so I don't know much else about this graph except here's 1, down here is 1/3. Horizontal asymptote could be something like this. As x gets super large, this thing gets closer and closer to 1/3. Okay. Summary of horizontal asymptote information. The horizontal asymptote of a rational function. Now remember, rational function is a polynomial divided by a polynomial. Those are the only ones we're considering. Can be determined by looking at the degrees of the numerator and the denominator. So we'll always start with the numerator at the bottom. If the numerator is the top. If the degree of the numerator is larger than the degree of the denominator, there's no horizontal asymptote. Which means as the inputs get super large, the outputs go off to infinity or negative infinity. If the degree of the top is smaller than the degree in the bottom, then we have a horizontal asymptote of y equals 0. As the input gets super large, the outputs get closer and closer to 0. And if the degree of the numerator is equal to the degree of the denominator, then y is equal to the ratio of the leading coefficients. That's the horizontal asymptote. And putting it all together. Find the x and y intercepts, horizontal and vertical asymptotes, and confirm these by looking at a graph. So we'll confirm them by looking at a graph with like Wolfram alpha. Okay. And so the first one is one that we've already looked at, but now we're going to analyze all the different components. The x and y intercepts, the horizontal and vertical asymptotes, and we'll look at a graph. So let me give you 1 quick minute to get ahead of me. Get as far as you can, and then I'm going to do it. Okay, somebody's not muted. If you can mute. Alright, so I'm going to do my x-intercept. I set my y equal to 0. 0 equals 3 over x minus 5. Now the only way a fraction can be 0 is if the top is 0, but the top is stuck at 3. So there is no x-intercept, because that has no solution. For the y-intercept, I set the opposite letter x equal to 0. And I'm going to get y equals 3 over negative 5, or negative 3/5. So when the x is 0, the y is negative 3/5. Horizontal and vertical asymptote. So let's do vertical asymptote first. I have to have that question memorized. What is the input that causes the denominator to be 0? The answer to that question, the input of 5. When x is 5, you'll get the denominator 0. Horizontal asymptote. I have the question memorized. As the inputs get super large, what happens to the output? Well, you get a fraction. But the top is stuck at 3 while the bottom keeps getting bigger and bigger, driving the whole fraction to 0. Horizontal asymptotes are always y equals. Vertical asymptotes are always x equals. So then, we've got all this information. Same problem we looked at earlier, but we hadn't had all the insights of, horizontal asymptote yet. So, here's negative 1, and negative 3/5 is right here, and at 5, we have a vertical asymptote, and then horizontal asymptote at 0. I'm going to just remind myself of that by putting these dotted lines over here. Now, I might guess over here and up here, going up and down, and I don't have to guess though. I could just say, alright, does this information jive, remember this 3 over x minus 5, with Wolfram alpha? And I go to Wolfram alpha, y equals 3 divided by, I gotta put this in parentheses, x minus 5. Now if you left out the word graph, and you just put the equation in, Wolfram alpha, we'll just try to guess what you mean, and one of the things it'll do is it'll graph it. Alright, now, you see it kind of gave us small graphs. If I put the word graph, did it do it a little bit bigger? Yeah, a little bit bigger. And it looks like a vertical asymptote at 5, and to the left it was below, to the right it was above, and so that makes sense with just putting this. Horizontal asymptote is 0, horizontal asymptote is 0, and then going up like this. Alright, so you see, we need these kind of stuff, these kind of graphs with these, if we're going to model things that are realistic, like when we were looking at, McDonald's, when they spent money on advertising, a realistic situation is something like this, with horizontal asymptote. And how are you going to be able to do that? This is how you do it with these polynomial over a polynomial. Okay. And this one. Do the same thing. Let me copy these instructions. Okay, I'm going to give you a quick minute to get ahead of me on this, and then I'm going to put everything up for that. Okay, on this one, 3x squared minus 9 over x minus 1. Oops. Goes over here. We'd already done this problem. We had found the x-intercepts, square root of 3, 0, negative square root of 3, 0, and the y-intercept, 0, 9. Okay, so let me go back to just write these in. The x-intercepts now, remember that was like negative 1.73. I might prefer it in that form when I graph it. Okay, and then the y-intercept was 0, 9. So that's the x and y intercepts. Now the horizontal and vertical asymptote. Vertical asymptote is really simple. What input causes the y to be, causes the denominator to be 0? When x is equal to 1. Horizontal asymptote takes a little more thinking. As x gets super large, what happens to the output? Well, it depends on which has larger degree. The numerator or denominator? The numerator has a larger degree, so it sends the fraction off to infinity. None. There is no horizontal asymptote. So we have all this information now, and I'll put it with the graph. So 1, 2, negative 1, negative 2, and then go up to 9. 1, 2, 3, 4, 5, 6, 8, 9. Okay, and then if I'm making my sketch, 1.73 somewhere around here, negative 1.73 somewhere around here. Okay, and my vertical asymptote is at x equal 1. And if you do it with a computer or a graphing calculator, it won't show you that dotted line, but we put it in. And then, alright, no horizontal asymptotes. It could be my graph goes way up. Could be it goes way down. I'm not sure, but I got this information. Let's see if this information is consistent with what I get in Wolfram alpha. 3x squared minus 9 over x minus 1. 3x squared minus 9 divided by x minus 1. Hit enter. And at vertical asymptote at 1 looks right. And it has x-intercept at negative 1.7, positive 1.7, y-intercept at 9. Everything is consistent. We could finish this graph out. This, and let me look again over here. It kind of goes up and then way down. And then this one to the right. It was doing this, arching out a little bit. That. And we've got it. Alright, so the homework. The only homework is to finish the section 5.6. Now, the schedule says that today we were supposed to be doing inverse and radical functions, but it just took us longer to get through 5.6. So I've built in buffers into the schedule. Next week we had a blank day on the last day of the week, so we'll wind up being caught up by the time that we finish next week. Alright, so I'll go ahead and I'll change the due dates though for the 5.7, 5.6, and 5.7. And, alright, are there any questions? Okay, if no questions, let me stop the recording.
Oh, actually, I was wondering if we're still doing the system that we had last semester, where after you submit the final version